Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to explain about partial fractions. Maybe some of you asking what is actually partial fraction. Yeah, partial fraction is a way of writing any rational function as a sum of simple rational function. All right. And from this statement arise another question, that is actually what is rational function? What is rational function? Yeah, rational function is just what we call quotient. It's a quotient of two polynomial. That is, we have one polynomial, that is, let's say p1x, okay, divided by or over another polynomial that we call p2x. Okay, this is what we call rational function. That is, when we have one polynomial, okay, that is, for example, like this one, p1x divided by another polynomial that we call p2x. Okay, for example, when we have something like this, at the numerator we have x squared plus 3, for example, over, we have another polynomial at the denominator. Suppose that we have x cubed, okay, minus 3x squared minus x plus 1, for example. Okay, here x squared plus 3 is a polynomial. At the denominator, we have x cubed minus 3x squared minus x plus 1, also a polynomial. This one also a polynomial. Therefore, the whole expression here, that is x squared plus 3 over x cubed minus 3x squared minus x plus 1, this is an example of a rational function. At these two rational functions, for example, I have 2 over x minus 4. Okay, we want to add that with 3 over x plus 1. Okay, how you add these two rational functions? So we say, okay, we take a common denominator. In this case, we have x minus 4 and multiply that, okay, by x plus 1. So at the denominator, we multiply x minus 4 and x plus 1. All right. Now at the numerator, we have to multiply 2 by x plus 1. And then we have to add that with 3 multiplied by x minus 4. And then what we do next is we have to simplify the numerator, that is, open all the brackets. So we have 2x, 2 times x is 2x plus 2 plus 3x minus 12 over x minus 4 multiplied by x plus 1, right? And again, at the numerator, we can combine like terms. For example, we have 2x here and we have 3x there. We can combine them, add them up together. So 2x plus 3x is, we have 5x. And okay, 2 and negative 12 is negative 10 over, we have x minus 4 and x plus 1. You see what happened here is that, okay, from two, what we call two simple rational function, that is this one and this one, we add them up together, okay, to produce, okay, a new rational function in which it is more complicated. Okay, this rational function on the right hand side here, that is 5x minus 10 over x minus 4 multiplied by x plus 1 at the denominator, is more complicated if we compare to each one of these rational function. Okay, so that is what happened here. That is, we add two simple rational function to produce a more complicated rational function. Now, for partial fraction, the process is reversed. Okay, that is, if we have a complicated rational function, how to write it as a sum of a simple rational function like this. Okay, for example, now the question, if we take this example, that is how to write down 5x, okay, minus 10 over x minus 4 multiplied by x plus 1, okay, is equal to what? Is equal to what? Okay, something here plus something there. Actually, the answer is, we know that is, okay, in this first circle here is 2 over x minus 4, and the other one is 3. Okay, this one is supposed to be 2 over x minus 4, and over here we have 3 over x plus 1. Okay, here we have 3 over x plus 1. Okay, now the question is how you come about doing that. That is how you produce, okay, how you produce, given the things on the left hand side, how you get this, okay, how you get these two rational function, that is 2 over x minus 4 and 3 over x plus 1. How you get that, okay, that is what we call the process of partial fraction decomposition. In this video, we are going to learn, okay, how to do partial fraction decomposition of type 1. Okay, that is when we have what we call distinct linear factors, okay, at the denominator. Okay, for example, if we have rational functions like this, right, x plus 1 over, we have x minus 3 at the denominator multiplied by x plus 2. Okay, for example, so this is an example of, okay, type 1. Okay, partial fraction type 1, because at the denominator we have this thing that is different, x minus 2 over here, and the other one is x plus 2. X minus 3 and x plus 2, they are distinct, means different, and they are linear at the same time. That is, the highest power of x here is 1. Now the highest power of x plus 2 is also 1. So both of them are linear factors, okay, at the denominator. So this is an example of partial fraction type 1. So that's what we are going to focus, okay, in this video. And we are going to show 3 ways, okay, how to do partial fraction for type 1. That is, number 1, we call it by using, okay, this is the methods that we are going to explain in this video. Methods that we are, okay, going to learn in this video is, number 1, that's by using the method what we call cover-up method. Cover-up method. Okay, number 2, we call it substitution method. Substitution method. And number 3, we are going to explain how to use comparing. Okay, comparing method. Now let's explain how to use cover-up method, okay, to do partial fraction decomposition. For example, this rational function here, 1 over x minus 1 at the denominator multiplied by x plus 2. So what we have to do first is we have to write down on the right hand side a over the first factor, that is x minus 1, plus b over the second factor, that is x plus 2. Now what we have to find out is what is the value for a and b. All right, so by using cover-up method, okay, what we have to do next is to find a. Okay, we write it down here. To find a, substitute x equal to 1 on the left hand side, okay, at the same time by covering or cancelling x minus 1. Okay, what happened if we do that is that, let's see, okay, as if on the left hand side we are going to cover by our fingers, you know, we close this one as if we don't see it. We close this one, and then we substitute x equal to 1 on the left hand side. We get x equal to 1. We get it from the denominator of the first rational function here, x minus 1. We set it equal to 0. We have x equal to 1. So we substitute on the left hand side x equal to 1. So we'll get the value for a. So a will be equal to 1 over, okay, x is equal to 1, so 1 plus 2. So we have a equal to 1 over 3. All right. Now, okay, the same process, what we have to do is to find b. Okay, to find b. Let's write down finding b. Now, to find b, what we have to do is we have to substitute x equal to, now this time we have to substitute from this factor here, x plus 2. When we solve x plus 2 equal to 0, we have x equal to negative 2. Therefore, we have to substitute x equal to negative 2 on the left hand side. And at the same time, we do covering. All right, we cover x plus 2. Okay, now this time on the left hand side we have, okay, let me write it down again. Okay, the left hand side, originally we have 1 over x minus 1, okay, multiplied by x plus 2 equal to a over x minus 1 plus b over x plus 2. Now, to find b, what we have to do is we have to cover, or as if that we can cancel x plus 2, okay, and substitute on the left hand side x equal to negative 2. So we will get our answer for b. So b will be equal to 1 over, we have x minus 1, when we substitute x equal to negative 2, so negative 2 minus 1, we have 1 over negative 3. So that's the value for b, that is negative 1 over 3. Okay, we also got already a equal to 1 over 3 over here. A equal to 1 over 3 and b equal to negative 1 over 3. Now we are ready to substitute the value for a equal to 1 over 3 over here, and substitute b equal to negative 1 over 3 in this expression there. So now for final answer, let's write down. Therefore, 1 over x minus 1 multiplied by x plus 2, we already find that is equal to a, that is a is equal to 1 over 3, just now we got it, x minus 1, okay, plus b, that is negative 1 over 3 over x plus 2. Okay, that's the Okay, the step that we have to write down, substitute x equal to 1 over 3 and b equal to negative 1 over 3. Now we should adjust or modify the way we write the final answer here, so that is more appropriate. So this one on the right hand side, we write like this: 1 over 3 multiplied by x minus 1, okay, minus 1 over, we have 3 also there, and we have the factor x plus 2. Okay, that is the what we call partial fraction for these terms on the left hand side. That is 1 over x minus 1, x plus 2, equal to 1 over 3 multiplied by x minus 1 minus 1 over 3 multiplied by x plus 2, okay, at the denominator. That's example number 1. Now this is example 2 for cover-up method. Okay, we are given on the left hand side x plus 4 over x plus 1 multiplied by x minus 2 multiplied by x plus 3. Now this is still okay in type 1, because all the factors at the denominator are all linear, distinct linear factors, right? So the right hand side we have to write is equal to a over the first factor, that is x plus 1, plus b over the second factor, that is x minus 2, plus c over the last factor, that is x plus 3. Now to find the value for a, okay, what we have to do is we are going to substitute, okay, to find the value for a. To find a, what we have to do is substitute x equal to negative 1 on the left hand side. At the same time, we have to cover x plus 1 on the right hand side, okay, on the left hand side. So if we do that, what happens is that we can find the value for a will be equal to, substitute x equal to negative 1. So we have negative 1 plus 4 over, now we have to cover x plus 1, meaning to say we are not going to substitute x equal to negative 1 in this factor. Okay, we substitute next x equal to negative 1 in the second factor, that is for x minus 2. So we have over here, we have negative 1, negative 2. Okay, in x plus 3, substitute x equal to negative 1, we have negative 1 plus 3, like that. Equal to 4 minus 1 is 3 over, we have negative 3 there. Negative 1 plus 3 is equal to 2. Alright, now this 3 and that 3 can cancel. So what we have is 1 over negative 1 over 2. Okay, that's the value for A. Okay, we already get the first value, that is the value for A. Now for B, okay, we do the same process for B. What we have to do to find B is we substitute x equal to, okay, substitute x equal to 2, okay, on the left hand side, and cover x minus 2. So if we do that, we'll get 2 plus 4, that is 6 over 2 plus 1 multiplied by, we have x plus 3, so we have 2 plus 3. This is equal to, we have 6 over, we have 3 here, and we have 2 plus 3 is equal to 5. Now this can cancel, 3 times 1, 3 times 2. So B equal to 2 over 5. Okay, we got that. Now to find C, what we have to do is, since at the denominator here is x plus 3, we are going to substitute x equal to negative 3 on the left hand side over here, okay, and at the same time we are going to cover or neglect x plus 3. So if we do that, okay, what we have is to find the value for c, we are going to substitute x equal to negative 3. Okay, therefore we can find the value for c. So negative 3, we have to add with 4 over, now x plus 1. So negative 3 plus 1. And then in the second factor, we have x minus 2. So negative 3 minus 2. Now let's simplify this. We have negative 3 plus 4 is equal to 1 over negative 3 plus 1 is negative 2 multiplied by negative 3, negative 2 is negative 5 equal to, this is 1 over 10. Alright, so we have 1 over 10 there. Now we are ready to substitute because we already get all value for the variable a, b, and c already. So we are ready to substitute the values that we have. Okay, on the right hand side here, we are going to substitute a over here, the value for b here, and the value for c. Okay, accordingly. So what we are going to write down is, now is our final answer. That is, we write again the question that we have, that is the rational function, original one, that is x plus 4 over, we have x plus 1 multiplied by x minus 2 and x plus 3. This equal to a over x plus 1. Okay, the value for a that we have is, a is negative 1/2, negative 1 over 2. So we have negative 1 over 2 over x plus 1 plus b. Okay, now let's look our step here. B is equal to 2 over 5. So we have 2 over 5 over x minus 2. And plus c. Okay, c we got over here, that is 1 over 10. So we have 1 over 10 over, we have x plus 3. Now let's modify or rewrite or simplify our answer on the right hand side here. Okay, therefore we can rewrite this like this. So we have negative 1, okay, over 2 multiplied by x plus 1 plus 2 over, we have 5 multiplied by x minus 2, and we have 1 over, and we have 10 over here multiplied by x plus 3. Okay, now that will be the final solution for example number 2 by using cover-up method. Now let's continue by explaining the second method that we can use to do partial fraction decomposition for type 1, that is when we have linear factors like this. Okay, so this is our example number 1, that is 2x squared minus 6 over x multiplied by x minus 2 multiplied by x plus 3 again. Okay, at the denominator we have distinct linear factors. Therefore, okay, this whole expression is of type 1. So on the right hand side, we can write as usual, okay, a equal to the first factor, that is x, okay, plus b over the second factor, that is x minus 2, and we have c, that is c over x plus 3. Okay, like this. Okay, now on the left hand side, let's take common denominator, that is we have x multiplied by x minus 2 multiplied by x plus 3. Alright, so a have to multiply by x minus 2 and x plus 3. Now for b have to multiply by x and also multiply by x plus 3. For c, have to multiply by c, multiply by x, and also x minus 2. Now, since the denominator on the left hand side and on the right hand side, they are equal, so we can write, okay, only the denominator, the numerator. So we can forget for a while the denominator, so we just write the numerator. So we have 2x squared minus 6 equal to, we have a multiplied by x minus 2, x plus 3, plus b multiplied by x, and we have x plus 3, and c multiplied by x, and we have x minus 2, like that. Okay, now to find a, okay, to find the value for a, we substitute. Let's write it down. Okay, to find the value for a, we substitute x equal to 0, okay, on the left hand side and right hand side. Okay, that's what we are going to do. To find the value for a, substitute x equal to 0. Where you get x equal to 0? From the first factor here, that is x, set it equal to 0. So if we substitute x equal to 0 on the left hand side, we have negative 6 equal to, we have a multiplied by negative 2 multiplied by 3 there, and the rest, they are all 0 because multiplying by 0, so we have 0 plus 0. Okay, so let's simplify this. Find the value for a. We have negative 6a equal to negative 6. Therefore, we have a equal to 1. Okay, we get already the first value, that is a equal to 1. Now to find b, okay, let's write it down. To find the value for b, okay, substitute, okay, x equal to find b, we substitute x equal to 2. Okay, substitute x equal to 2 on left hand side and right hand side. Now if we do that, then what happened is we have, okay, on the left hand side, when x equal to 2, so we have 2 square is 4. 4 times 2 is 8. 8 minus 6, we have 8 minus 6 on the left hand side equal to, when x equal to 2, okay, that term will cancel, plus b, we have to multiply by 2, multiply by 2 plus 3, that is 2 plus 3. Okay, and the last term here for c also, we are going to have that term also will go to 0. Okay, because we have here x minus 2. So when we substitute x equal to 2, 2 minus 2 is equal to 0. Okay, we have this value is 0 because when we substitute x equal to 2, we have all this term is equal to 0 because we are multiplying by 0. Okay, let's simplify and find for b. In this case, we have 2 there. We have, so b multiplied by 2 and multiplied by 2 plus 3 is 5. So we have 10b equal to 2. Therefore, in this case, we have b equal to 2 over 10 or equal to 1 over 5. Okay, we got that. Now, to find c, Let's continue to find C. We substitute x equal to -3, okay, on left hand side and right hand side, and see what happened. Okay, so x equal to -3 this time. Okay, so this is our expression there, to x squared minus 6. Okay, let's write it down again. Okay, so we have 2x squared minus 6 equal to, we have a, we have x minus 2, we have x plus 3, okay, plus b, we have x plus 3, we have cx multiplied by x minus 2 there. So when we substitute x equal to -3, okay, this term will cancel, this term also will cancel, go to 0. Okay, so -3 squared, 9 times 2 is 18, minus 6 equal to, we have c multiplied by -3 and multiplied by -3 minus 2. So we have 18 minus 6 is, we have 12 there. We have c multiplied by -3 multiplied by -3, -2 is -5. Okay, so we have 12 equal to c multiplied by 5 times 3 is 15, positive. So we have c equal to 12 over 15, or we can simplify this one, 3 times 4, 12, 3 times 5. Okay, so we have c equal to 4 over 5. And we already got, okay, everything that we need. So a equal to 1. Let's write down our answer all together. Okay, we have a equal to 1. B, let's see, check it out. B, we have 1 over 5. B equal to 1 over 5, and C we already got there, 4 over 5. Okay, and then we are going to substitute the value for A, B, and C over here. Okay, substitute A, substitute B, and substitute C. Okay, therefore we can write down our final answer. Like this. That is, we have 2x squared minus 6 over x multiplied by x minus 2 multiplied by x plus 3. Okay, this is equal to a, that is a equal to 1 over x, plus b, that is 1 over 5 over x minus 2, and plus c, that is c equal to 4 over 5 over x plus 3. Okay, now let's simplify our answer on the right hand side. This is equal to 1 over x, okay, plus 1 over 5 x minus 2, and plus 4 over 5 multiplied by x plus 3. Okay, that will be the final answer for example related to substitution method. Okay, this is the last method that we are going to discuss concerning doing what we call decomposition of partial fraction of type 1. Now we have this example here. In this case, we are given x over x squared minus 1. Okay, we are going to decompose, okay, by using what we call comparison method. Okay, so on the right hand side, okay, like usual, we write down as a over, now we have to, to factorize the denominator first. Okay, this denominator over here we have to factorize. So this one we have to write down x square minus 1 square. Okay, we can factorize like this, x minus 1 and x plus 1, right? So actually the what we call the left hand side, okay, we can write down first as x over x minus 1 multiplied by x plus 1, like this. Okay, then and only then we write down a as a over x minus 1 plus, okay, another number we call b over x plus 1. Okay, so what we need to do first, as I did here, is that we have to factorize the denominator first. Okay, x squared minus 1, write it down as x minus 1 multiplied by x plus 1. Okay, see, we see this problem also is of type 1 because they have what we call distinct linear factors. X minus 1 and x plus 1, they are distinct. At the same time, they are linear factors. Okay, so we have on the right hand side a over x minus 1 plus b over x plus 1. What's left is to find the value for a and b. So let's take common denominator. On the left hand side we have x minus 1 and x plus 1, like this. Okay, a have to multiply by x plus 1 plus b have to multiply by x minus 1. Okay, again, when we look on the left hand side and the right hand side, they have common, the same denominator, so we can forget about the denominator for the time being, and we just write down the numerator. So on the left hand side we have the numerator x, so we have x equal to, on the right hand side we have a multiplied by x plus 1 plus b multiplied by x minus 1 as the numerator. So what we have to do, okay, next is we have to expand the terms on the right hand side. We have x equal to, that's the left hand side. The right hand side we have a multiplied by x, we have ax plus a plus we have bx minus b. Okay, we collect like terms, combine like terms together. So on the left hand side still we have x. Okay, ax and bx, they are like terms, so we can combine them, a plus b, and we factorize x outside. And the terms without x is a minus b, so we put them together in one bracket like that. So now we compare between left and right hand side, okay, in terms of the coefficient, I mean. So here the coefficient for x is equal to 1 on the left hand side. On the right hand side, the coefficient for x is a plus b. Therefore, by comparing, we see that a plus b is equal to 1. Okay, that's our first equation. So we are going to write down the equation. Okay, the first one, that is a plus b is equal to 1. Why equal to 1? Because the coefficient on the left hand side for x is equal to 1. Okay, this is equation number 1. We label it equation number 1 like this. Now for the terms without x, or what we call the constant, on the left hand side we don't have it, meaning the constant component is equal to 0. And the right hand side, the constant component is a minus b. Therefore a minus b, therefore a minus b is equal to 0. This will be our equation number 2. Now we have two equations here, and we have two unknown, that is a and b. We can solve that, okay, by using simultaneous equation. Now maybe we can cancel b first. Okay, now let's add equation number 1 with equation number 2 and see what we get. We have a plus a, we have 2a. Okay, b plus negative b is cancelled, we have 0. And on the right hand side, 1 plus 0 is equal to 1. Therefore, a equal to 1 half. Okay, we got the value for a already. Now, from equation number 2, what we have is a equal to b, right? A equal to b. Therefore, since a equal to 1 half, therefore b also equal to 1 over 2, 1 half. Okay, so we already find the value for a. We also have already the value for b, both of them 1 half. And lastly, what we are going to do is we are going to substitute the value for a, okay, and b over here, the value for a and the value for b, both of them 1 over 2 or 1 half we call it. So let's substitute. Okay, just now on the left hand side we have this equation, that is we have x. Let's write it down here. Okay, by using different color, we have x. Okay, we have x over x squared minus 1 is equal to a. Okay, we have a is equal to 1 half over x minus 1 plus we also have 1 half over x plus 1. Okay, let's simplify the terms. On the right hand side we have 1 over 2 x minus 1 plus 1 over 2 multiplied by x plus 1. Okay, now that's complete the process of doing what we call decomposition of partial fraction by using comparison method. Okay, see here in this example we compare left hand side and right hand side, okay, to produce these two simultaneous equation, and we solve it by using cancellation, or maybe we can use it by substitution, to find the value for a and b. And then, okay, lastly we write down our final answer by substituting the value for a and b, and then we simplify. Okay.